Hi guys, I am going to go through these pages with you. It's 11 to 14 in the packet, and I'm going to do the best I can writing. I forgot my stylus, so I'm using my finger, but I hope you can read what I'm writing. All right, so consider the compound inequality -5 is less than x is less than 4. Rewrite as a compound statement of inequality. So when you're doing that, you're splitting from the middle. So you're looking backwards and you're going to say x is greater than -5, and you're splitting from the middle, x is less than 4. That's a compound inequality. Okay? Write the interval notation. So I'm actually going to look at the original one, and it starts at -5. There's no equal bar, so that's a curve. And it stops at 4. There's no equal bar, so that's a curve. Write a sentence describing the possible values of x. So I hope I can type text. Okay, that will help a lot. X is between -5 and 4. So you're really just describing it in words. If you want to get fancy, you could say x such that x is a real number between -5 and 4. Okay? Graph. So back to drawing. Okay. So there's an open circle at -5. There's a there's an open circle at 4, and these are connected. Okay. Sometimes it's easier to do the graph before the interval notation. If that is something you want to do, that's perfectly acceptable. Like, just because this is the order doesn't mean it's the order you have to do it in. Okay? All right, here we go. Rewrite the inequality as a compound statement. So again, you split from the middle. So you have 2x plus 1. And if you're looking at it kind of like sideways, it's greater than -5. And then a split from the middle again. So 2x plus 1 is less than 4. Okay. Solve each inequality for x and then write as a compound inequality. Okay, so I'm going to solve each of these. All right. So if I subtract 1 from both sides, I get 2x is greater than -6. Divide by 2, I get x is greater than -3. So that one's solved. Okay. So subtract 1 from both sides, you get 2x is less than 3. Divide both sides by 2, you get x is less than 1.5. Okay, and you could leave it as 3/2. You can write 1.5. You can write 1.5, whatever you want. And then they're saying write the solution to the compound inequality. Okay, so when they're connected, it's an and statement. So I'm going to write it using the word and. Okay, so I'm actually gonna type it again so you guys can read it better. Okay, so I want to start with the x is greater than -3. So I'm going to do -3 is less than x. And you're kind of reading it backwards. -3 is less than x. And then x is less than 1.5. So when you write this compound inequality, it's always less than less than. I mean, it could be less than or equal, but it's always less than less than. So you always want to start with the smallest number. Okay? Can you solve it if it had stayed one statement? Yeah, of course you can. You just got to do things in 3 places. So like, you know how we always say, like, what you do to one side, you do to the other. There's going to be 3 sides. I mean, they're not really sides, but whatever. Okay, so I definitely can. So I have -5 is less than 2x plus 1. And the good thing is we already know the answer, right? Is less than 4. All right, so I'm going to subtract 1, but I have to subtract it in 3 places. So it's sort of like left, middle, right. -6 is less than 2x is less than 3. Then I'm going to divide everything by 2, and that gives me that answer right there. Okay, so now I'm going to graph it. Open circle, open circle, and you just got to go between 1 and 2 and connect. Those are circles. I know they don't look like circles. They kind of look like sixes, but you get the idea. All right? So listen, like you pause the video, you take a second, you look at it, make sure, if you have any questions, shoot me an email. All right, here we go. Turning the page. All right. What must be true in order for the compound inequality to be a true statement? Well, this is an or statement. So, in order for an, I'm going to put these in quotes, or statement to be true, only one part needs to be true. Now, both parts can be true, not necessarily in this case, but only one part needs to be true. Okay. Write a sentence describing the possible values of x. Okay, so we're just going to put this in words, all right? X is less than -3, or, that's important, it can't say and, it has to say or. X is greater than -1. Graph the solution set on the number line below. Okay, so I'm making an open circle. Got to get my finger going again. Here we go. An open circle at -3, and it's less than. And then an open circle at -1, and it's greater than. Okay? You can make the circles like on the number line or slightly above. It's really not a big deal. Okay? But open is a big deal, and left or right is a big deal. Okay, open circle because there is no equal bar. Left for less, right for greater. Trying to roll my R, I'm not very good at that. You need Miss Kelly for that. Okay, so x plus 4 is less than 6, or x minus 1 is greater than 3. So solve. Okay, so if I subtract 4 from both sides, I get x is less than 2. Or if I add 1 to both sides, I get x is greater than 4. Write those as a compound inequality. Okay, so basically to write that as a compound inequality, the only thing you can do is change the or to that v. So it's like x is less than 2, v for or, x is greater than 4. You can combine them into like one, like 2 to 4 thing because it's not an and. Okay? Whenever it's an or, it can't be made into like a single with just one letter x. It always needs both letter x's. Okay. So write a sentence describing all possible values. X is less than 2, or x is greater than 4. Now, sometimes they expect you to get fancy and be like sort of like that set notation, like x is a number such that. This is not fancy right now. If they want fancy, give them fancy. All right, so now this, x is less than 2, so I'm going to draw. Okay, so x is less than 2. Here's 2. Open circle, and less than goes left. Always put that arrow, even though that doesn't look that great. And then 4. Open circle, 4. There we go. In this case, like this, it can't be both. It's one or the other. One or the other. Okay. And that's like the difference between exclusive or and inclusive or, but not the point right now. Okay. So solve and graph. Okay. So I'm going to solve -6 to both sides. So x is less than 2. Add 1 to both sides. So x is greater than 0. And this is an and. So whenever it's an and, start with the smallest number is less than x is less than 2. Okay? Whenever it's an and, you're going to connect them. You always start with the smallest number. So you go from left to right, smallest to greatest. All right, number line. Oh, it would have been really good if I had a number line on this paper, but okay, number line. So you just need a few points and try to evenly space them. So like -1, 0, 1, 2, 3, 4. Open circle at 0, open circle at 2, and they're connected. Ands connect. And, or. And, or. Okay. I probably look like an idiot, but whatever. Okay, so this one I'm going to solve. I'm going to subtract 3, subtract 3, subtract 3. That gives me -4 is less than or equal to -2x is less than or equal to 7. Divide by -2. Now, this is fancy stuff. When you divide by a negative, you flip the inequality signs. So, this is going to be 2 is greater than or equal to x is greater than or equal to -3.5. I went decimal. Now, that's technically it's like backwards. You want to rewrite that, okay? So that should be -3.5 is less than or equal to x is less than or equal to 2. You always go from least to greatest. So even though this is a true statement, absolutely a true statement, this is truthful. It's just not properly written. This is properly written, okay? All right, so number line. Oh, look at this, lines. Sometimes I love when I find things. I'm going to put a line like this. Okay. Line. Psh. And of course it doesn't show up because I didn't save the changes. All right, line. There's a line. Just imagine it has arrows on it. Maybe give it a one more go. Click. I'll give it one more go. Fine. Line. Done. Okay. So here's -3.5. And let's say -2, -1, 0, 1, and 2. Closed circle, connected. Okay? All right. I am not going to do them all with you, but I'm going to keep going. Okay? So subtract 1, subtract 1. You have 5x is less than -1. Divide by 5, divide by 5. X is less than -1/5. It's a fraction and you will survive. Okay, so +5 plus 5. 13 is less than or equal to x, so x is greater than or equal to 13. This is an or. So let's say that this is -5, and then this is 0, and then this is 5, and then this is 10. So this is approximately here, and then approximately here, and that's colored in. And listen, it's not perfect. If it was a test, I would give you the fancy number line with the numbers on it, and you would be happy. Okay? All right, I'm going to do one more with you. Okay, so add 2, add 2. You get 12 is greater than 3x. Divide by 3, divide by 3. You get 4 is greater than x, which means x is less than 4. Okay, you kind of have to like look at it sideways, right? This is solved already. Or x is equal to 4. That's actually x is less than or equal to 4. That's this. So number line. Boom, 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 boom. I hope you guys are having a good day. 2, 3, 4, 5, 6, 7. Don't think I'm having fun. I mean, I'm having fun making this video, but when you are watching this video, I am spending the day in a meeting with the state education department, which is good for you. Not exactly fun for me, but I will sacrifice so that you can get a better Regents exam. Okay, this looks good. All right, so listen. Do E by yourself. Do F by yourself. Take some time. If you're watching this alone, pause. If you're watching this as a class, pause. And then go on to page 14. Okay? Hope you have a great day. maybe I'll do, no, you guys can do this. You're good. I believe in you. Keep going without me. Have a great day.